Hi everyone, welcome to Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we're having a presentation by one of our students. His name is João, and he's going to be showing us how he did his project for the course that we offer, our ROS Basics in 5 days, in which he programs a real robot, a Turtlebot, in order to command it to do an algorithm that follows a along the walls of the environment we have set up here. So he's going to be showing us how he did that with topics, services, and actions, which are the basics of ROS. So hi, Zhao, how are you?
Hi, I'm good, thank you.
Great. So yeah, whenever you want, you can start
Okay,
sharing your screen and show us what you did for your project.
okay, so
All right,
here is the robot.
we can see your screen.
Gonna gonna launch the main program. I put some warning um, and info just to see what the robot is doing.
So
Now
if you can
is
explain while it's
yeah,
doing its
exactly.
thing.
So okay, it was a bit fast, but first he called the service to find the wall.
Mm-hmm.
I put him next to the wall, so he just starts checking what is the minimum distance that I have,
Mm-hmm.
and then he it it sees if I should go right or left depending on the ID of the index, sorry, of the closest ray of the laser. And
Right.
then it starts turning. It then starts going forward until it's on like 30 centimeters of the wall,
Uh-huh.
and then it turns left so it can face the proper direction,
But
basically.
can I ask you a question?
Yeah,
Well, I guess you can tell us a little later once you go into the code. How did
yeah.
you do this output of the terminal so it's kind of refreshing?
Oh, so I just called uh, the module, the system module.
Oh, okay.
So
Then
it,
we can.
and then call clear of the terminal. It
Oh,
was
nice.
just easier
Yeah,
to
because then
see.
it's overwhelming after a
Yeah,
while.
exactly, exactly.
I've also seen this program where, not program, I think it's a method that it leaves so it would be like left, right, and
Yeah,
only the number would be updated. But I have, that's also a nice
yeah,
thing. But
exactly. So the speed of the turning is like a linear relation that I did. I wanted to spend more time in this, but since I'm doing my thesis, I
mm,
couldn't.
I
But
understand.
so it depends on how far is it from the goal, which is like around 30 centimeters from the wall.
Okay.
So it just depending how far it just turns more aggressively or less aggressive,
Right. Right.
and it has like a cap, so it doesn't turn like two times the speed uh, two, so
Right.
it doesn't. Yeah, so exactly. So it would like start turning around too much if it got too far from the wall,
I see.
basically.
I see.
I don't know. I have the can check the action too. So I'm gonna start the feedback, echoing the feedback. I hope the result. So it tells the current total. So I just grab the the positions, like I don't know the rate now, but it just grabs the positions and calculates the different distances
Mm-hmm.
and adds up to the total. So
Okay.
when it does a full turn, I have like a threshold, um, that so that I know, like, because it's not gonna stop.
We have
It's
our
not gonna
colleague here.
stop. It's not gonna stop at the same spot that it started, or it cannot pass through the same space sometimes. So
Okay.
I
Yeah.
have just a little threshold, so it knows that when it stops. I think it's gonna stop soon. Yeah, exactly. So it has the all the
Oh, it
points
outputs all the
that I took.
points,
Yeah.
and and then I'm assuming the feedback goes back to zero,
The feedback,
or just stops after one lap.
uh, I had to check that, but I think it goes back to zero.
Okay, okay,
Actually, it starts on the program. It was just easier to show this way.
right. Okay, well,
Um,
it looks like it works really well. Uh,
yeah.
so if you,
Actually, I was having some problems with until like 10 minutes ago
oh
because
really?
it would crash. But I found that giving because when he was approaching the wall, it was too late and then it just crashed. So
It,
I raised the distance of like the
of the
detection
front
of the
detection,
front wall
right?
to around 55 centimeters. So it stopped doing that.
So it turns earlier. Okay,
Yeah, exactly.
okay, great. Well, now that we know that the behavior works, which is the most important part, could you please just go a little bit through
So
each
the code.
section in your code and
Yeah.
explain how you did it?
Can I stop the
Yeah, yeah.
program?
We can stop this because we can see that everything works well.
So I think we can start maybe on the service.
Yeah, let's do the
Um,
service and then I don't know, the main program and then the actions.
yeah. Okay. So I defined the callback here. I I put I put I tried to organize this in classes too.
Nice.
So maybe I have here the main classes. So I have the laser, which just saves the topic and the laser values.
Mm-hmm.
Um, I then created like a robot object just to have these stop functions, move forward, move left, move right, and also the main uh, wall following,
Mm-hmm.
basically. Um, so here it starts the laser object with the scan topic. It starts a publisher for the velocity of the wheels, and it also waits for the service node to be ready,
Mm-hmm.
the find wall, um, and also the action. So here in the service node, I have it starts the node, and then it starts this service of the find wall
Okay.
that I had to create. It's here. The it just has the response, the wall found, like the notebook said. So
Right.
um,
And when do you get that wall found? Uh, that result when the robot is at a certain distance, or how?
I just put true when it finished when it's in the right position. So it turns
Oh,
to
when it's
it
lined
goes
up with the
forward to
wall.
yeah, exactly. So
Okay.
it goes to the wall, going going in front, going
Mm-hmm.
forward, sorry, and then it turns right, I think, so or left, and then it returns through.
Right. And how'd you do that turn with just turning a certain amount of time, or just
No, I just turned to I saved
the
the
odometry?
yeah, exactly. I
Yeah.
saved the position, the distance, sorry, and then when it reaches a certain, I add a little threshold too, so it can pick up.
Okay.
Um, it just turns and faces has I think it's the 270 index facing the wall.
Yeah.
It stops. So and yeah, so I also tried uh, firstly to because I noticed these cones.
Mm-hmm.
So I wanted it to start in a random place, not just close to the wall.
Exactly. That was my
So
next question.
yeah, and it worked on the simulator, but then going to the real robot, it just didn't. But basically, this was the
Oh.
algorithm. I can explain. So it just grabs the values and then it checks for drops,
Or
sudden
dropped.
drops like this. And it also, to eliminate these parts that stick out, it also has, it also checks like a 30 index to the front, to the from the end, because it starts here and it ends here, for example.
Right.
So it has like a buffer of 30 indexes
So if it's
that it,
30, you know it's an obstacle, basically. If it's
yeah.
uh-huh.
So exactly. So it's not for that. It's just to eliminate these spikes, because in these little spaces it would create these spikes.
Mm-hmm.
So to do that, I just when it stops, it checks also the 30 indexes in the front, and if it notices another drop, then it doesn't cut here, it continues
Oh,
um,
I see. I see. I
giving
see.
the, like, I put 2, so I knew it would be above every distance possible,
Mm-hmm.
and then it just checks for the minimum value, which in this case would be 0.4. And it would be the same, but um, so what I have here, it's a much simpler version, which is just check for the minimum and go there.
Right.
And it it is kind of limiting because the robot has to be
If
close
you're
to the wall,
going,
but
if you're near an obstacle, it's going to go towards
yeah,
that, and that's
exactly.
why you did that filter.
But exactly, but I couldn't do that in the, maybe I could, I just didn't have the time
Right.
in the real one, because it was just choppy, the values weren't
Oh, I was
like,
gonna ask you, why do you think that
yeah,
is?
exactly.
It's there's more
I
noise, maybe?
It's not noise, it's just choppy. Maybe I can show you.
Yeah, maybe we can
Let me try.
see this in our vis
So
or
ROS, uh, let's run. Well, find maybe it can, maybe it can work. Sometimes it did work, but like you see, it's just
oh,
choppier.
this might be
I don't know why, but yeah. So
so it looks like it's missing some values.
yeah, exactly.
Oh wow.
And I also did put that in the like the review of when I
Mm-hmm.
finish like testing here. I don't know if you guys
You might have
have seen
discovered
it,
a
but
hardware
yeah.
issue right now that because this lighter's been running for a long time, so maybe it's
Oh, maybe, yeah.
and I've noticed that in these cheaper lighters, when they start failing, they start doing this. So instead of
Oh, okay. So
outputting,
maybe that's the problem, yeah.
yeah, yeah, that well, that's interesting. So I'll take that a look at that to
Okay.
see if that's the case. But that's a really nice implementation of distinguishing an obstacle versus the wall. That's really nice.
Yeah, so to continue like
Hmm.
the service, um the server. So like I said, I have this threshold which will be useful later, and it just waits for the laser to get
I have
some values. It waits a bit, um, and then it gets the values. I just put I just find here the minimum distance. Actually, I didn't need this. It was for the other code. I forgot to take it out. It prints just to. It was just more like a debug thing.
mm,
Um, and then it finds the. It starts moving right or left depending on which one is closer to the distance.
right.
And like I implement here the threshold. Then it moves forward, and if it's until it's less than 30 centimeters, it stops. Um, and then it also moves left until the actually it's the front value that I put here, because I
Mm,
noticed I don't know if it's the same issue with the LiDAR, but I noticed when I put the 270 index, it just stopped really early. I don't know why. It was almost
oh,
facing the wall when it started, so I put the front value.
all right.
Um, and yeah, so it just says the service started, and then it goes here to the to the main one. Um, it initializes the maybe I can check the action too. So here I did a class for the action too. I tried to do this as object oriented as possible,
Mm-hmm.
um, and with my experience. So yeah, it starts the action server. I created the action the action
Message.
um, message. Yeah, exactly. Thank you. Um, and um, and then it also has a subscriber for the odometry. This is just a, a function to get the distance between 2 points.
Yeah, and then you.
Um, this is the callback, which just stores the position and the total values, the total distance,
Mm-hmm.
and then um, yeah. So at first, so is close to the objective. So at first, I just give them 2 times the threshold, so I know it started and
Oh, okay,
it's
okay.
going. So it didn't stop right there because it just found
Then otherwise it'd be
the
like, oh, I'm at the goal and
yeah,
time to
exactly.
stop.
So it would just stop. Yeah.
Oh, okay.
It also has the preempt algorithm.
Mm-hmm.
So yeah, it just appends to the list. It returns the feedback. It publishes the feedback, and if it succeeds, it returns it it sets the goal as succeeded. Sorry.
Right.
So yeah, um, going to the main one, then it starts the robot object. It then starts the service of find the nearest wall, which just calls the 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 proxy.
Mm-hmm.
Yeah. It then starts the action. It sends a goal to the action too, and the main process, which is the start while following. So, okay. So here it also waits for the laser to get some values. This is the multiplier that I was talking about, the linear
Oh,
relationship
yeah, yeah.
between the velocity and the distance. Um, and yeah, this is the thing that you're asking about, the OS system. It just
Oh,
calls
oh, okay, okay.
the clear on the terminal, and it clears everything. It then just gives me the front, left, right, and right values. Um, and here it fits this is the front distance, so the forward distance to the wall. If it's greater than 55, it just starts moving left really aggressively. I have a 0.7,
And that's the
uh,
goes with
and
the
forward.
multiplier, right?
No. This
What was
is
the 0.7?
the 0.7 is the velocity going to the left. So the velocity given to the
Oh,
wheels
so
to go
the
left.
z angular is will be zero point 0.7.
Exactly.
Oh,
Yeah.
okay.
Sorry, I can show you here too. Um,
No,
the
no, I was just wondering.
move left. So yeah, it just gives the angular
Oh, I
z,
see. I see. I
and
see.
it publishes once, and it gives this message too.
Okay.
Um, the other ones are similar.
Mm-hmm.
Yeah, just the move forward is the x. It's here, the x, and yeah, that's the only difference. So here I also just decreased a bit the 30 centimeters because I thought it was going too far from the wall. Um, and here is the the relationship. So I have the minimum distance between the right value of the laser and the value that I want,
Mm-hmm.
and it multiplies that for the rotational velocity multiplier. And if it's yeah, this minimum is to check to cap the velocity so it doesn't go crazy.
Right.
So yeah, if it's higher than 0.4, it just caps the velocity at that point.
Okay.
The right is this is just like a buffer, a little buffer that I have of 2 centimeters between this and this. Um, and yeah, so this was to stop the infinite values that sometimes appeared. Uh, Maybe it's because of
That's just the
that
nature of all
issue.
lighters.
Yeah,
If they're
exactly.
too close, sometimes they just
Yeah,
show infinite.
exactly.
Yeah.
So yeah, this was an attempt to, I don't know if this really works, but this was an attempt
So
to
if
do
it's
that.
yeah, okay, okay. So if it's
Yeah,
super high,
and
yeah.
so if it's aligned, or if it doesn't detect any of these conditions, it just assumes it's aligned
And it moves over.
and it stops rotating and moves forward. I also noticed that, like in the simulator, I just needed to call the I just needed to publish once, and
Mm,
it would never stop doing
right.
that movement.
Yeah.
While in the real one, it's different.
Yes,
So
you have to give it a rate. Yeah,
yeah,
because a lot of the
that,
times the robots have like a, I don't know if that's like a safety or something that you have to publish continuously for it to keep moving.
yeah,
Um,
yeah. So yeah, I just had some issue with that at first because I wasn't understanding why isn't it moving.
mm-hmm.
But then I understood that I needed to keep publishing, and I altered the code to do that. So yeah, I think I covered
Yeah, you did.
everything.
That's it.
So
So,
yeah,
do you mind stop sharing your screen so we
yeah,
can
no,
just talk about it? All right. Well, congratulations, Zhao. That's a really nice project, and
thank you.
I told you I was going to ask you questions at the end, but I
Yeah,
kind of did it throughout the
yeah, it's okay.
presentation. I hope
It's
that
easier,
wasn't
I think. Yeah,
too interrupting.
no, no,
Uh, but I thought it's a really nice project. Things that I just liked that I thought were really nice were, first of all, that filter you implemented
yeah,
that detects whether or not there's an obstacle or the wall. That's really nice. We only had a couple of people that have attempted it, and um, it sucks that you kind of discovered that
yeah,
issue with the lighter that prevents the uh, the for the simulation it works, and
yeah,
in the real robot it doesn't. But that's something that we also tried to uh,
improve.
offer with this switching to the real robot. For example, that rate of publishing that is different, and obviously we can see that there's a there's an issue with that lighter, but if you're working with
Real one,
a
it's gonna
real
be
one, you're gonna have these issues.
close to
So
that. Yeah,
there's sometimes you have to deal with them. Sometimes you just buy another one. So I thought that
yeah,
was really nice. I also thought the terminal thing was it's just nice to see.
yeah,
Instead of like having to scroll back to trying to find what you want, and I really liked the way you used your thresholds and buffers to in order. That's really useful too for the real robot to have
mm,
those kind of checks. For example, the to make sure that the robot didn't start right at the beginning. I thought
yeah,
that was really nice, and I mean your use of classes was really nice, and it made the main program super simple. It's like
yeah,
do the service, do the main
yeah.
program,
That was
and
the
do the action,
objective.
and that's
Yeah,
it. So I thought that was really cool. Oh, and last thing I noticed that the velocity control you implemented for it to not turn as hard, and I thought that was a really good addition. That it's outside of the scope that what we asked, but
yeah.
it's also really nice to see. And but yeah, that's kind of what I thought. Really nice project, Joe.
Thank you, thank you.
And I mean that's it from us. So guys, you saw Zhao here do his project. So if you want to take our course and get your certificate, all you need to do is do what Zhao did here. And I'm really impressed by what you did, Zhao, and you went above and beyond. So congratulations.
Thank you. Thank you. Yeah, it's a really good course actually. I got the I think that I'm capable of. Uh, I understood most of the things
Oh, I'm
of
glad that
ROS. Yeah,
that's our goal in that course. So I'm glad
yeah,
it was helpful for you.
yeah. It was. It's good value actually. So
Great. Super happy to hear that. Super happy. So,
thank you.
anyways, thank you so much, Zhao. I hope we can see you around for more courses if you're more interested. So,
Yeah,
anyways,
I will. I will when I have more time.
all right, all right, guys. So that's it for us here at becoming a ROS developer. So we'll see you for the next presentation. Goodbye.
Bye.
Okay, I ended the stream.
Okay.
Nice, 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 nice.